today's lesson, we're going to take a look at fraction review number 2. And our first question looks something like this. Russell spent 1/3 of his allowance to go to the movies. He wants to buy a new video game that will cost him another 1/2 of his allowance. If he buys the game, how much of his allowance will he have spent? So right off the bat, you know what your math job is, and it's hidden right in that question. So if he does buy the game and goes to the movies, how much of his allowance will he have spent? So that's what we're trying to find out. How much he will have spent. We'll jump up to the first sentence. Russell spent 1/3 of his allowance to go to the movies. So 1/3 on the movies. So Russell spent 1/3 on the movies. Okay, wants to buy a video game that will cost him 1/2 of his allowance. So we got 1/3 of his allowance and 1/2 of his allowance. So if you're trying to figure out how much of his allowance he spent in total, hopefully that tells you that you're going to add. So we'll take 1/3 plus 1/2. So he spent 1/3 going to the movies and 1/2 on the video game. So we'll take a look at this. I think we'll solve it 2 ways. First of all, we'll go with, why don't we try the array method first? So I'm going to extend my page out, and then I'm going to bounce back up and do the traditional method. So it was 1/3 plus 1/2. I'm going to rewrite that. 1/3 plus 1/2. And I want to show an array. So remember, when you're adding or subtracting fractions, you have to come up with a common denominator. And really, showing the array is one method of doing that. So how do we set up that array? Well, I'm looking at these denominators. I've got 3, and I have 2. So that tells me I can have a 3 by 2 array for each of these fractions. 1, 2, 3 by 2. So we'll have that, and then we'll also draw another one for the second fraction. And now we'll show these fractions, 1/3 plus 1/2 on these arrays. So we look at the denominator. 3 tells us to look at groups of 3. And there we have a group of 3 and another group of 3. Then we bounce up to the numerator, right up there, and it says, okay, we're going to focus upon 1 out of 3. So 1 out of 3 I X'd out, and 1 out of 3 of that set of 3 I'll X out. So it's 1/3, 1/3, okay. And that gives me a new fraction, one that's equivalent to 1/3. And I'm looking at that array. It has 6 parts that make up the whole array. And I've X'd out 1, 2 of those. So I can add 2, 6 plus, and we're going to be getting another equivalent fraction for 1/2. So let's take a look at that. 1/2. The denominator tells us 2. You're probably thinking, we have to look at groups of 2. Exactly. Okay. Now, numerator, 1. Just like that first fraction, 1/3. 1 is our numerator for 1/2. So now I'm going to X out 1 out of 2 there. 1/2 of these, 1 out of 2 there. And that leaves me with, okay, an array that has 6 parts in it. So that's my denominator. That takes 6 parts to make that whole array. And we focused upon 3 of those. So I have 3, 6, and you can simply add those up now that we have the same denominator. I mean, technically you could take these x's and move them over here, and you'd see that if I could cover that up, there we go. If you added those together, it would be 5, 6. I'm going to put those back over there, move that one back. So now you see 2 plus 3 equals 5, and your answer would be 5, 6. So if he buys the game, how much of his allowance will he have spent? And his name was Russell, I believe, up here. Yep. Okay, so we can answer that in a sentence now. Russell will have spent there it is, 5/6. 5/6 of his allowance. Now you could also, solve this the traditional way that I originally learned when I was going through school. So let's divide up this workspace here. And we'll take a look at the original problem I wrote down up here. 1/3 plus 1/2. Now you could go through the steps of the LCM and you'd find the multiples of those two denominators. And so you'd be finding multiples of 3, multiples of 2, and you could just multiply those out. 3 times 1 equals 3. 3 times 2 equals 6. 3 times 3 equals 9. You might be saying to yourself, oh, Mr. Mariner, can you stop? Well, you'd be right. It's because now we've got 2 times 1 would equal 2. 2 times 3 equals 6. And there you have it. There is your lowest common multiple. So your LCM equals 6. And once you find your LCM, you got yourself a new denominator. So you just have to convert 1/3 and 1/2 to 6. So you say to yourself, okay, 2 times what equals 6? You're probably thinking you already know that over here. 2 times 3 equals 6. What you do to the denominator, you have to do to the numerator. So that would be 1 times 3 is 3, so that would be 3/6. Now we do the same thing. 3 times what equals 6? Right here, there's your proof. 3 times 2 equals 6. 1 times 2 equals 2. Now you can add those up, and again, you're going to get 5/6. Yep, there it is. Same, we originally got 5/6 that he spent out of his allowance, and we have 5/6 again. So there's the answer to that problem. Now we'll take a look at problem number 2. We've got 3 2/3 times 1 5/6. We've got two mixed numbers, and in order to multiply those, you really should change them to improper fractions. So I'm going to represent our whole numbers with pi's, our mixed numbers actually. And let's see, we'll take some copies of these. All right, so now we can show three 2/3 first, and then we'll be able to convert those to improper fractions. So we'll do 3 2/3, and then let me divide the workspace so we don't get to avoid any confusion. And down there, eventually, we're going to get to 1 5/6. So we'll do one circle to show the 1, and another one for the 5/8. 5/6, I mean. Okay, so now what I want to do is I'm going to show 3 2/3 on these circles. So if you've got 3 2/3, we've got 3 holes shaded in. It can be just a rough sketch to show the 3. There's 3, and now I have to show 2/3 of another pi. Let's try this. We'll divide down and try to get thirds. They should technically be equal parts. Just kind of show that a rough sketch there to show our ideas. Now we're going to do 2/3 of this pie. And now, how would we show this as an improper fraction? Well, I noticed that this fraction already has a denominator, and, well, a numerator as well. So the denominator is thirds. So we divided this pie into 3 equal parts. What I'm going to do is go back to the whole pies and divide them up. I mean, they could be pies, they could be sandwiches, they could be cakes, could be really anything imaginable. So now we got 3 wholes and 2/3 of another. So if you look at this, you've got a denominator of 3 because it's divided up into 3 parts for this circle here, and we've got 3 equal parts. 3 out of 3. Same for this one, 3 out of 3. And 3 out of 3 for that one. So if you added those all up, you could do that because the denominators are the same. So we have 3 plus 3 is 6. 6 plus 3 is 9. 9 plus 2 is 11. So we've got 11 thirds. So instead of 2/3, we've got, or I'm sorry, 2 and 2/3. We've got a mixed number that we can work with. And that would be 11 thirds. So let's move this around a little bit. And now, okay, 11 thirds. Now we'll have to multiply it by 1 and 5/6, and we'll change that to an improper fraction. Again, we've got 1 whole. And then we've got 5/6 of another. So I'm thinking, okay, I've got to divide that into 6 equal parts. Try to divide this fairly evenly. Okay, pretty close. And we got 5/6 out of this one. I really should use black for that, so I'm going to change my shading for this. So we got 1, 2, 3, 4, 5 out of 6. So that's my fraction 5/6. Now to change 1 and 5/6 to an improper fraction, we'll take a look at this whole. So we're going to divide it the same way we did with the 5/6. Again, they should be equal parts. I'm just kind of showing you a rough sketch here. So now we've got 6 equal parts makes up that whole, and we have 6 parts. Now you can add these two together. Since the denominators are the same, we just keep them the same when we're adding or subtracting fractions. Now we add the numerators. 6 plus 5 is 11. We'll take a look at that. So we've got 11/6. 11/6. And what, 11 thirds times 11/6. Now you can do 11 times 11. You can multiply that out. 1 times 1 is 1. 1 times 1 is 1. And then we'll work in the tens place for this one here. 1 times 1 would be 1. 1 times 1 would be 1. Some people like a placeholder 0. That's fine if you do that. And we want to add those up. And you'd get 121. So now our numerator will be 121 over 3 times 6. Hopefully you know that common fact, that basic fact, and that is 18. So now you're left with an improper fraction again. So how could you change that back to a mixed number if you were asked to do so? Well, let's create, I'm going to rewrite it down below. That was 121/18. 121/18. And you can read every fraction as a division problem, so it would be 121 divided by 18. So now you can think of yourself, 18 goes into 121 how many times? Well, 18 doesn't really fit into 1. So that would be like 0 times. So 0 times 18 would be 0. You can go through these steps. Bring down the 2. Now you've got 12. 18. Does 18 fit into 12? Well, no. Not one full time. Not any whole number times. So now we've got 0 times 18 equals 0. We subtract. We get 12. And we're left with the original number we started with in the dividend up there. So 18 goes into 121 how many times? Well, I'm thinking to myself, 18, let's try, 5. 5 is easy to work with. Let's try it. 5 times 8 equals 40. 5 times 1 is 5, plus the 4 would be 90. Well, it's close to 121, but I think we can get a little closer. So let's try 18 times 6. 8 times 6 is 48. You're probably thinking that too. Good for you. 6 times 1 is 6, and 6 plus 4 is 10. Ah, that's nice and close. I think we're as close as we're going to get to 121 without going over. So now we've got 18 times 6. So 6 times 18 equals 108. Subtract, you get, let's see, 1 minus 8, you can't really do without getting a negative number, so let's do this. We'll borrow, that becomes 1, that becomes 11, 11 minus 8, 3, 1 minus 0 is 1, and 1 minus 1 is 0, so we're left with 13 as a remainder, and when you're working with fractions, your divisor over there can become your denominator. So we have 6 and 13 18ths. And that would be the answer to this problem. 6 and 13 18ths. And now we'll take a look at the third problem in fraction review number 2. And it goes like this. Joe's mom makes healthy brownies. She uses 1 2/3 cups of white flour and 2 1/8 cups of wheat flour. How much flour does she use to make the brownies? And you can see our job in that last sentence once again. It's often found there. So you're trying to find out how much flour she used to make the brownies. So it really sounds like an altogether type problem. So let's take a look at the rest of the sentences. Joe's mom makes healthy brownies. Well, that's story information. She uses 1 2/3 cups white flour, and, oh, look at that. That's a clue that you're going to add, you're probably thinking. Good for you. 2 1/8 cups of wheat flour. Okay. How much flour does she use to make the brownies? Well, both are types of flour. So we can just take those mixed numbers and add them up. So we had 2 1/8, that was the wheat flour, 1 2/3 was the white flour. And you need to add them up. I'm going to take a look at the LCM method for this. So let's try it out. LCM, lowest common multiple. Multiples of what, you might be thinking? Well, fortunately, we have a couple of friendly denominators over here, and they're going to help us out. Because you really want to find the multiples of those. Multiples of 3 and multiples of 8. Let's shake things up a little bit and do multiples of 8 first. We've got 8 times 1 equals 8. 8 times 2 equals 16. 8 times 3 equals 24. Oh, that's interesting. Right off the bat, my third one in, I see the number 3. Oh, that makes sense. I bet you, and you might be thinking to yourself that, yep, 8 times 3 is probably the LCM. And you'd be right. Because if you really, multiplied out all the multiples of 3, you go 3 times 1 is 3, 3 times 2 is 6, and you continue that until you got to 3 times 8, and that would equal 24. And that would be your LCM. And like we noticed before, if you find an LCM, that equals 24. And once you do that, you've got yourself a new denominator for your fraction part of the mixed numbers. And we have to convert the fraction part to 24ths. So 8 times what equals 24? You're probably thinking 3. And you'd be right. So it's 8 times 3 equals 24. And 1 times 3 equals 3. What you do to the denominator, you must do to the numerator. 3 times something equals 24. And if you're not sure, you can go back over here at your multiples work and just say, oh yeah, 8 times 3 or 3 times 8. Either way, they come up with the same product. So 3 times 8 equals 24. So multiply that numerator by 8. 2 times 8 equals 16. Now you've got something you can work with. You've got 6/24 plus, well, it was, if you go back, it was addition. That was our operation. Trying to find the total amount of flour in there. 16/24 plus 3/24. And we could add that up, and don't forget to add the whole number part too. So you have to add 1 plus 2. Let's do that now. All right, 16/24 plus 3/24 equals 19, because 16 plus 3 is 19, and our denominator stays the same now. And we're going to add up 1 plus 2, and that would be 3. So if you squeeze those together, you get 3 and 19/24. So how much flour does she use to make the brownies? She uses, or used, 3 and 19/24 cups of flour. And there you have it. There's the answer to that problem. Thanks for checking out Mr. Merrick's EduBlog, and we will see you again next time.